All right, we're going to take a little journey, a journey through the cosmos. We're going to start with the absolutely terrifying silence of space. Then we'll dive into some of the mind-bending physics that make it all work, and we'll end with the incredible, and I mean incredible, truth about where we all come from. So, let's dive in.
You know this line, right? From the movie. It's meant to give you a shiver, to set a scary mood. But here's the crazy part. It's not just a movie line. It is a 100% scientific fact.
And the reason is, well, pretty simple really. Space is a vacuum, a near-perfect one. And sound waves need something to travel through. They need to vibrate molecules, like in air or water. Without that, nothing. So you can imagine the biggest explosion you can think of, like a star tearing itself apart in a supernova. And it all happens in complete, total, bone-chilling silence. And that silence, it fills a space so vast, it's almost impossible to get your head around. So let's try, just for a second, to understand the sheer, overwhelming emptiness of it all.
Yeah, just reading that, you kind of feel it, right? That sense of being completely overwhelmed. Truth is, our brains just aren't wired for this kind of scale. But we can use analogies to at least try to get a glimpse.
This one always gets me. Imagine you're holding a single, tiny grain of sand. That's our sun. Now, to find the next nearest star, you'd have to walk 4 miles to find another single grain of sand. And all that space in between, it's just empty.
Okay, so it's a whole lot of nothing. But it's not entirely nothing. Sprinkled throughout that emptiness are some of the most bizarre, most wonderful things you could ever imagine. Places that push our understanding of physics right to the edge.
So check this out. There's this planet called 55 Cancri E. It's about double the size of Earth, but it's so close to its star that its whole year, one full trip around, takes only 18 hours. And because it's so hot and packed with carbon, scientists think a huge chunk of it, maybe even a third, is pure diamond. Seriously, a planet made of diamonds.
And diamond planets? That's just the tip of the iceberg. The universe is also filled with the ghosts of dead stars. And some of them leave behind these things called neutron stars. And when I say dense, that word doesn't even begin to cover it. I mean, just look at that number, 6 billion tons. That's how much a single teaspoon of stuff from a neutron star would weigh. To put that in perspective, that's like taking over 900 of the Great Pyramids of Giza and squishing all of that weight into a single teaspoon.
It's a wild thought, isn't it? The gravity inside one of these things is so powerful, it literally smashes atoms. So yeah, if you took every single human being on the planet, all 8 billion of us, and compressed us to that same density, we'd all fit inside one little sugar cube.
Okay, so when you get gravity that intense, something else starts to get really weird. I'm talking about time itself.
You see, Albert Einstein figured out that massive objects don't just pull on things with gravity. They actually warp the very fabric of space and time around them. Think of it like putting a bowling ball on a trampoline. The heavier the object, the deeper the dent it makes, and the slower time moves in that dent.
And get this, you don't have to fly off into deep space to see this in action. It's happening to you right now. Because your head is just a little bit farther away from the Earth's center of gravity than your feet are, time is actually ticking just a tiny bit faster for your head. Your own body is a time machine.
Now, it's a ridiculously small difference, of course. Over your entire life, your head might age about 90 billionths of a second more than your feet. But this isn't just a fun little trivia fact. It's actually super important for technology we use every day, like GPS. The satellites orbiting Earth experience time faster than we do. And if engineers didn't correct for it, your GPS would be off by several miles every single day. So that's what a little bit of gravity does. Which begs the question, what happens when you turn that gravity dial all the way up to 11, like near a black hole?
Well, once you get close to a black hole's event horizon, that's the point of no return, gravity gets so extreme that time practically grinds to a halt. You could spend what feels like just a few hours there, fly back to Earth, and find that hundreds, maybe even thousands of years had passed. Everyone and everything you ever knew would be gone.
So after all that, the crazy distances, the diamond planets, the time-bending black holes, it's pretty easy to feel, kind of small. But there's one last piece to this puzzle, and it's the one that connects every single one of us to all of that cosmic chaos.
See, right after the Big Bang, the universe was, well, it was pretty basic. It was pretty much just hydrogen and helium, the two simplest elements. All the stuff we're made of, carbon, oxygen, iron, you name it, it just wasn't around yet. So,
Where did it all come from? It was forged deep inside the fiery hearts of giant stars. For millions of years, they acted like giant cosmic furnaces, fusing those simple elements into heavier ones. And then, when those stars died, they went out with a bang, a supernova, blasting all those newly made elements out into the galaxy. And that dust, that stardust, eventually came together to form new stars, new planets, and you.
The great astronomer Carl Sagan put it perfectly. Think about it. The carbon that makes up your body, the iron in your blood, the calcium in your bones, every atom in you that isn't hydrogen or helium was cooked up inside a star that died billions of years ago.
So you're not just some random observer in the universe. The universe is literally inside you. We are the legacy of ancient exploded stars. We are the universe become aware. We are, quite literally, stardust.